Hey, Miss Marion here. We are looking at Unit 3, Lesson 2. So make sure you have your workbook, get it out. We're going to be taking some notes on this and understanding different pieces of the vocabulary that we talked about last Friday. So go ahead and get it out and let's go. All right, so to our underlying question that we're going to be asking ourselves today is, how do I describe key features of a function? And remember, a function is kind of something that is one-to-one, right? Remember that. And so like a y equals mx plus b or y equals 2x plus 3 is a function, and we're going to be kind of looking at this kind of stuff and some other stuff that we haven't done before. All right, kind of starting this, Alonzo, Maria, and Sierra were floating in inner tubes down a river, enjoying their day. Alonzo noticed that sometimes the water was much deeper in some places than in others. Maria noticed there were times they seemed to be moving faster than at other times. Sierra laughed and said, "Math is everywhere." I agree on that. Oh, and also we're on page 16. All right, also on page 16, we can actually see this table. It says part 1, to learn more about the river, Alonzo and Maria collected data throughout their trip. Here was Alonzo's data table about the depths of the water as they flowed along. Number 1, so this is on page 16, use the data that Alonzo collected in the table to interpret the key features of this relationship. So remember, we're looking for key features. So what are things that we can talk about this table that Alonzo has? So go ahead and pause, write down some stuff, and then come back to me, and so we'll know if we've covered everything. All right, so let's go ahead and kind of talk about some stuff. First of all, our domain are all the x values, right? And the domain is going to be the time pieces of information. Our domain goes from 0 all the way up to 120. And then we have our range, right? And what is our range? And then we actually, so if we wanted to look at it, so let's do domain. And the way that we go ahead and talk about our domain, we're going to do the curly brackets, and our domain are all those x values. So 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120. And then our range is all of our y values. Range, and then our curly bracket, and these are, as you look at it, these are the particular points that are on this table. So we have 4, 6, 8, 10, 6, 5, 4, 5, 7, 12, 9, 6.5, and 5. And then also when we're writing this down, we actually don't write numbers down twice. So I'm actually going to erase the 5 that's twice, and also the 6 that's twice. And a lot of times we also write it in order. But right now, this is totally fine. This is something we've learned. And I'm going to move this up. All right, other key features that we can talk about. Do we have a maximum? Right? And we're looking at, and it's the y values that we're looking for, or the depth in feet. And we're looking for that maximum. Is there a number that is the biggest? Okay, well, that's 12. Let's also look at the minimum. The minimum, smallest number on the y's. Notice how it's 4. We have 4 twice, and that's okay, right? We also want to find out where it's increasing and where it's decreasing. And again, we're looking at the y values. Let's put this in blue. So notice how this is increasing. And then notice how the y values, this is decreasing. We have it increasing again. And then we're decreasing. Okay. So these are key features of this table, and it really kind of shows us a lot of information that's going on. So make sure you write the stuff down and then come back to me. All right, so normally we would discuss about this, and notice how we have our domain or range, X and Y axis are intervals, right? Maximum, minimum. Intervals of increasing or decreasing. Is the relationship continuous? Oh, we didn't do that one, right? So does this relationship keep on going on, or does it repeat itself over and over again? Yes, we can consider that this is actually continuous. And then is it a function? Or are all the X values, are all of them different? Well, yeah, they are. So is this a function? Yes, it is. All right, here is part 2. This is actually on, 16 to 17. So Maria created a graph by collecting data on the GPS unit that provided the distance she had traveled over a period of time. Describe the key features, okay, of the relationship shown in Maria's graph. Include intervals of increasing, decreasing, domain, range, maximum, minimum, and the intercepts. Okay, so go ahead and write down these answers and then come back to me. All right, so let's go ahead and go through this. I'm going to move it up, gives you a little bit more room. So we want to go ahead and write down our domain. Right, and domain are all the X values. So where does this start? Well, notice how we start at 0, and then we're going to go all the way up to like 120. So we are going to go ahead and we're going to do a bracket. So that includes the 0, and then goes all the way up to 120, and it includes it. So again, this is interval notation. We're writing this as interval notation. Let's find our range. Our range, let's put that, make it R. Range are all the Y values. Where do the Y values start? Well, they start at 0. And then it's going to go all the way up to, so that it's going to start at 0. And it goes up probably around 16,000, maybe 15,000, okay? That is our Y values because it goes all the way up. So 10, 1, 2, 3, 4, maybe 15,000. Another 0. All right, next we want to talk about the intervals of increasing. So intervals of increasing. Okay, so again, we're looking at the Y values as far as where it is. And so, well, let's put down the time frame as far as where it's increasing. So we're going to start at 0, and we're going to go all the way up to 120 minutes. All right. And then where is it decreasing? So interval of decreasing. Does this graph, does it decrease? No, it doesn't. So never, none. Okay. We also want to look at our maximum. Maximum does come from the Y values, right? So our maximum is 16 or 15,000 feet. I would take either 16 or 15,000, okay? Where's the minimum? Where's the lowest point? Minimum. Where's the lowest point that's on here? Okay, so that is, so we're going to say the, I want to write the maximum in a word sentence, okay? So we're going to say the maximum is at 16,000 feet, traveled at 120 minutes. So we could say, oh yeah, the maximum is 16,000 feet, but we can also write it a little bit more information. Where did that actually happen is also where we kind of need to know. So let's do the same thing with the minimum. So the minimum, okay, where does that actually have? So where is that? It's at 0 feet, right? It doesn't tell us a lot of information, so let's write in a sentence. The minimum is, I guess we kind of just need is in that. 0 feet traveled at 0 seconds, right? So it's at that beginning point, right? And then one thing that we didn't talk about last time is we need to figure out the x-intercept. We need to figure out the y-intercept. So x-intercept. Remember the x-intercept, it's where that line crosses the x-axis. So where does the line cross the x-axis? Well, where does that happen here? Well, that's going to be at 0, 0. And then we can do the same thing for the y-intercept. But we're asking, so I'm going to kind of move this up a little bit. Where does the line cross the y-axis? Well, that also happened to be at 0, 0. So these are key features of this graph. All right, so we're going to go ahead and we're going to, Sierra kind of does some questions and we're going to agree or disagree with it. This is also on page, well, it starts on page 17 and goes to 18. Sierra looked at the data collected by her 2 friends and made several of her own observations. Again, we're trying to see if it's true or false. And so the depth of the water increases and decreases throughout the 120 minutes floating down the river. So do you agree or disagree? B, the distance traveled is always increasing. You can agree or disagree. And the distance traveled is a function of time. Okay, so answer just those 3 and then come back to me. All right, the depth of the water increases and decreases throughout the 120 minutes. Yeah, I agree. So you can kind of look at the table. So if you look at Alonzo's table, it's going up and down kind of stuff. The distance traveled is always increasing. Okay, so yes, the distance that they did from where they started, where they ended, that comes from the graph, yes. Does the distance traveled is a function of time? Are all the x values different? Or you can do your pencil line test and see if it also, and so both of those are true. All right, D, we're going to answer the D through I. D, the distance traveled is greatest during the last 10 minutes of the trip than during any other 10 minutes interval of the time. The domain of the distance/time graph is all real numbers. So we're looking at the domain. The y-intercept of the depth of the water over time is a function. Over time function is 0, 0. The distance traveled increases and decreases over time. The depth of the water is never 11 feet. And then the range of the distance over time graph is from 0 all the way up to 15,000. So go ahead and answer those questions and then come back to me. All right, so let's go ahead and go through these. D, the distance traveled is greatest during the last 10 minutes of the trip. Well, no, I mean, we're looking at, so what we're doing is okay, the distance over the last 10 minutes is more than most 10-minute intervals. However, it is not as much as the distance traveled at 40 to 50 minutes. So you're looking at kind of between the intervals, where is it the most that they traveled the most? So that's why I'm disagreeing with that one. E, the domain of the distance over time graph is all real numbers. I'm going to go ahead and disagree on that because our domain only goes from 0 to 120. So they're saying it's all the numbers in the world, but actually our domain goes from 0 to 120. So I disagree. The y-intercept of the depth of the water over time function is 0, 0. If we look at this, we are looking at our y-intercept, right? So that's not our y-intercept. And so we don't agree with that one, right? If we look at G, the distance traveled increases and decreases over time. Our distance is always increasing because they're doing the distance from where they started from, and you're always increasing. So that's false. H, the depth of the water is never 11 feet. The depth of the water changes from 7 to 12 feet between 80 and 90 minutes into the trip. So the water level would be 11 feet, but it can also drop at any time. So that's why I went ahead and disagreed with that. And then the range of the distance over time graph is from 0 to 15,000. The range, we said it was 16,000. So right now I'm going to say no, I disagree because of how the graph is actually set up. So these are our answers, and make sure you copy them down. All right, let's answer the last four. So J, the domain of the depth of the water with respect to time is from 0 all the way to 120. The range of the depth of water over time is from 4 to 5. The distance over time graph has no maximum value, and the depth of the water reaches a maximum of 30 minutes. Go ahead and answer those and then come back to me. All right, here we have our answers. So number one, yes, I do agree. The domain does go from 0 to 120. The range, we disagree because the range went from 0 to 16,000, so that doesn't work. The distance over time graph has no maximum value. We actually did have a maximum value. We actually had that in there. That was 16,000 feet, so I disagree. And the depth of the water reached a maximum of 30 feet. That actually is, I disagree because it also doesn't go along with our max. So there you go for the last four. All right, so thinking about again, okay, so what are some of the key features that we can go ahead and look at functions and pictures and those kind of things. We want to make sure that we are looking at the domain. We're looking at the range. We're looking at the maximum, the minimum, our y-intercept, x-intercept. Where is it increasing? Where is it decreasing? So there's a lot of stuff we can actually look at both on the table and the graph to actually figure out exactly everything that's going on. Because if we combine both the table and the graph together, it gives us a lot more information than when we first started out. All right, so here is some key takeaways, and I forgot to put that page on there. Our takeaways are actually on page 20. Right, some of them is that our range for the minimum lowest y to the maximum greatest y value. So the range is actually the lowest y and the highest y. Maximum, we want to look where the function changes from increasing to decreasing. That's where our maximum is. Minimum, we want to find out where the function changes from decreasing to increasing. And then we can also have our endpoints that also do that. The interval increasing, it marks where the y values start to increase and where it stops increasing. And so I would actually write all these down. If you need to write them on page 21, because you have room on there, I would actually go ahead and write those down. These are really good ideas as far as what we have been able to learn for today. Here are also some more. So intervals are always written from the smallest value to the greatest value. If the endpoint is included in the interval, we need to go ahead and use brackets. We kind of talked about that with well, it was actually unit 4. If the endpoints is not included, then we're going to use our parentheses. Again, we talked about that. And then interval notation is only used to describe continuous intervals. So if it kind of keeps on breaking, we do it a different way. I would also write these on, and honestly, I would write these on page 21 because you have a lot more room. All right, so if we want to make sure we understood everything that's going on, so interval of increasing, so we can write it as 2 comma and then with the bracket of 6. I did not include the 2 because I don't know exactly where it changes as far as the interval of increasing itself. Because if you look at it, we're writing down the x values, but it does actually change somewhere in between these two things, right? So because I don't know where exactly it changes, I'm going to put a parentheses instead. But I do know, because I can kind of do it this way. So this is where our parentheses, because I don't know exactly, and then it goes all the way up to here because it's going to end here. Interval of decreasing, okay, where is that? So we're looking at it. And so it's where it is decreasing, we're looking at these numbers here, right? So I do know it does include, I need that in black. I do know it does include -1, so we're going to do bracket -1. And then I don't know where exactly it's going to go ahead and stop as far as decreasing itself. So I do know it does start with 6 and it does go all the way up to -1. Notice how we did write these because we're looking at all the y values. So it does start with 16 and it does decrease and keeps on going down. But I'm writing it as the lowest x value to the highest x value. Okay. And then our domain are x values. So our domain, where does it start? -1. Where does it end? +6. And then our range are our y values. Where does it start? So we're going to write the lowest number, which is 0. And then the highest number, which is 16. And we're going to include those because that's actually part of the table. So these are things that we're supposed to learn for today. All right, so we're doing our practice problems, and yes, we go ahead and put them in Canvas. Make sure you get that stuff done, and I will see you later. Have a good day. Thanks. Bye.